Putney Bridge over the River Thames in London. My name is Trevor Philpott and I'm a television reporter, and for the past 8 years I've been making film reports twice a week for BBC television. The subjects have ranged from war in Vietnam to Playboy clubs in Chicago, from steel in Australia to shipbuilding in Japan. And I'm here this morning because I've been asked to report on the company whose headquarter buildings look down on the Thames from either side of this bridge. They go by the initials ICT, International Computers and Tabulators. And they're very much in the news in Britain these days, with very good reason.
ICT are by far the biggest manufacturers of computers outside the United States. They're spread all over the United Kingdom, and they've got centres in 50-odd countries around the world. What makes them interesting to a British reporter is that for some time they've been the pace-setters in the drive towards newer ideas and newer products, and their latest bid for the computer market, the 1900, is the most remarkable thing that has happened so far in the British computer industry. The man at the top is Basil de Ferranti, one of the youngest men in England to be managing director of a company of such size. Although the company is spread around Britain, he's in close and constant touch through flying visits in his helicopter. He's a qualified pilot, and usually he flies it himself. He's 34, a Cambridge Honours graduate in engineering, and grandson of the famous Sebastian de Ferranti, who pioneered the use of electric power half a century ago. ICT's biggest factory is at Stevenage, 30 miles north of London. They've got a production engineering shop which is becoming something of a showplace to British engineers. A senior ICT engineer spends all his time combing the world, looking at every new machine tool wherever it's made that might be an improvement for productivity and precision on the ones already in use. The result is a shop floor that's a sort of industrial United Nations, with over $100 worth of equipment to every square foot of floor. ICT themselves take all this pretty much for granted, but you couldn't say that of all their visitors. They also take it for granted that any modern manufacturer has got to use numerical control on his machine tools. The back wiring on their central processors is performed under the control of a tape produced on one of their own computers. This machine, too, is something of an eye-opener for their visitors, not just because it only takes an hour to turn out piece parts which still spend 20 weeks in the workshops of many European firms, but also because ICT have worked out an extremely clear and simple programming language specifically for this machine. As well as the most advanced machine tools, ICT have now gathered together nearly all the best computer brains in Britain. No one really disputes the high quality of their thinkers and designers. As they'll tell you, they've been in data processing for 50 years, and they produced the world's first commercial computer and the world's largest computer. Now all their combined brains and experience have gone into the latest and most successful of all their computers, the ICT 1900 series. It's the world's first fully compatible range with a new standard interface concept. The concept which makes it possible for any combination of peripherals to be connected to any processor, or combination of processors, by a simple plug and socket connection. It has had tremendous success since it was announced in September 1964, and is revolutionizing the attitude of British commerce and industry to the computer. 7 models in the series have already been announced, all compatible upwards and downwards. 7 processors and about 40 peripherals permute to more configurations than anyone is likely to need in this century. ICT are also pretty pleased with their executive program, which communicates with the operator in a very simple language on a console typewriter. They point out that as well as controlling operations, it's always looking out for faults and errors in peripherals and reporting them. ICT are also talking a lot about their standard interface. They claim they were onto it first, and that they already have the most comprehensive model in the world actually in operation. All the peripherals work to it, not just some of them, and they plug into the processor so easily that all the peripherals can be delivered separately to the user and just plugged in when they arrive. And of course, they can all signal back to the processor. The larger processors are assembled at ICT's Manchester factory. Here too, the first batch is on final test, and one has already been installed on customers' premises. All the larger processors are multi-programming. They get very cross if you talk about time sharing. They say time sharing is just what makes it possible for multi-programming to start. These machines can run anything from 4 to 16 utterly separate programs at the same time, with a fully controlled system of priorities. The core store isn't static, it's constantly and automatically reallocated. There's no obligation for any of the simultaneous programs running on these machines to be real-time, or for the programmers to take any other programs into account, or even to know what they are. Of all the latest computer developments, ICT claim that this is the biggest money saver and biggest money maker. Although ICT's multi-programming is almost certainly the most advanced on the market, it's not in fact anything new to them. It's already been in use for over 2 years on their Orion computers, which can run anything up to 16 programs at the same time. Here at their service bureau in London's West End, they handle masses of customers' data, but no one has ever had to wait more than 24 hours for his results. And all the lessons learned on Orion have been built into the new 1900. Chapter 1 of the ICT 1900 story ended on March the 15th, 1965, when the first system, a 1905, was officially inaugurated at the Northampton College of Advanced Technology in London. The first production model from a standard interface, fully compatible, multi-programming series to be operational anywhere in the world.
All that sounds very impressive if considered in isolation. But ICT are not the only computer manufacturer in the business. Far from it. The world is straddled by one giant competitor, well established in every market from San Francisco through Rome to Tokyo. Who are the men behind this new ICT drive? And what hopes can they really have of getting a sizable share of the world computer market? Well, let's go inside and meet some of them.
The man behind the 1900 sales drive is Deputy Managing Director Arthur Humphries.
You've got to sell your 1900 against the competition of a very big competitor, and one who can spend as many millions as may be necessary on promoting their product. How can you fight that?
We fight it by having confidence in the product and generating our sales force with this spirit of confidence. With the 1900 range, we made a significant breakthrough in publicising the significance of the product. It achieves an important step forward for our customers in taking the obsolescence risk out of ordering a computer. This has come about by a unique situation of making all the units in the system easily connectable. This is what we call our standard interface. The concept was ours, we were the first, others have followed.
How can you overcome the conviction that the bigger and the more widespread the company, the better the spares supply and the service are likely to be?
Well, our belief is that the quality of service absolutely depends on the quality of people. And the quality of our staff matches the highest standards set by anyone. Britain is a small country, but by the quality of its people, it has set very high standards in the world of achievement. ICT can do this and is determined to do it. We may not be the largest or even the second largest company in this business. For this reason, we try harder.
But the difficulties in selling in this American-dominated market must be immense. How and where do you start?
Well, we're going to start, of course, to develop our substantial business in the United Kingdom and also to develop our overseas business. We intend to make a determined effort in the Commonwealth territories and also in Europe.
What kind of a share have you got already in the UK and in Commonwealth countries?
We have the preponderance of the market in the United Kingdom, such as 70 or 80%, taking into account the whole of data processing equipment. Business in the overseas territories of the Commonwealth is about 35%, but in Europe it is only small at the moment.
How are you going to make a start in Europe?
By a spearhead attack. We believe that the broad front approach is not appropriate to our business, but we must have high quality staff who seek out new and unique applications for our equipment. Our equipment is highly suitable to unique applications, and combining systems know-how and advanced techniques in multi-programming and time-sharing will enable us to make successful business, to get successful business, and to find unique applications where we can have an answer which is beyond the approach of our competitors.
Has this spearhead attack scored any victories yet?
It has indeed, because we were successful in securing the business from the Berlin Senate against a large number of competitors, both in Europe and from America. The significance here was that we had a unique application. The system which we were proposed and which appealed to the customer demanded time sharing and multi-programming and expertise and know-how about what those terms meant. they judge that we knew better about these subjects than anyone else. We were also able to be competitive in terms of price and delivery.
Now, much of your growth, and you do plan an enormous growth rate, has got to come from new customers and from new uses of the machine. Who are these people, and what are the uses that the computer may be put to that it's not being put to already?
Well, the people, or the customers, are everywhere and are infinite in quantity. The new applications go to infinity. Computers can no longer be regarded as quill pens that are capable of doing clerical work very fast and therefore cheaper, but as real instruments of management. More importantly, to be used to save money, not only to save money, but to make money. A computer can be used as a tool of management to plan the destiny of the company, its growth and its future. It is for this use and purpose that they should be used, and this is the application of the future of the most significance.
Head of the planning division is Graham Morris, a man who knows the 1900 to the last transistor.
Now, your production presently is concentrated entirely on the 1900. By this range of computers, you stand or fall. What capabilities has it got, do you think, that are going to make it stand?
Can I make one thing quite clear to start with? Our concentration is on the 1900 so far as the computer range is concerned, but don't forget that ICT manufactures a wide range of other equipment as well.
Oh, I meant as far as computers.
Absolutely. So far as computers are concerned, the 1900 is the cornerstone of the company, and we believe there are several fields in which its strength lies. First of all, of course, lies the fact that it's a range of products. It gives the potential user a choice, a wide choice, from which he can select just what he wants for his particular application. This is greatly assisted by the standard interface concept which we have adopted, which will greatly facilitate the exchange of one peripheral unit for another, or the addition of a further one subsequently. So this is the really key thing. If I can just go on, another factor, of course, is the value for money which the system offers. And as a result of many studies we've done, we have assessed that the 1900 offers first-class value for money over a wide range of applications.
Now, I believe at least one of your competitors also has a matching range of computers. Has your machine got any qualities that they haven't got?
Indeed it does, but one first point is the importance of not singling out any single facet of a machine, any particular unit, any particular facility, and saying this is what rules the roost. It's the balance of the system that counts, not any particular one. But there's one thing I would like to make a little song and dance about, and that's the multi-programming facilities of the larger systems in the 1900 series. This is a field in which ICT has got a very great deal of experience as a result of our work with, for example, Orion and Atlas, and these experiences have been accumulated and built into the 1900, offering therefore very much greater power and potential to big users in the larger systems.
You've mentioned value for money several times. Now, generally, how do your prices compare with those of competitors for a similar system?
You can do lots of theoretical exercises on this and please yourself in your private deliberations as to how good you are. What really matters, of course, is how you get on the job. And on the job, we find that in real competitive situations, our prices work out often as much as 10% less than those quoted by our competitors. This is a sort of general rule. It varies, but roughly we are very happy with the results.
ICT are obviously very pleased with the 1900, but might not some designers within the industry criticize you for not including some of the recently developed techniques? Why, for instance, are you using printed circuit boards instead of monolithic chips?
Again, you've picked on one facet. Again, what matters is the system as a whole. However, to answer the particular point, at any stage of development in technology, the designer has the awful problem of deciding between using something which is tried and tested, which has very many attractions, and on the other hand, something which is new, glamorous, sexy, even sometimes so-called, and potentially cheaper. At the time our choice was made for the 1900, and even still today, our view is that great reliability can be achieved by the circuitry we use. The costs we know, we don't conjecture, we know what the costs are, and that we're therefore able to offer our system at the right price. It is true that the use of monolithics or integrated circuitry or whatever other fancy term you like, that this may in the future bring down the cost. It may increase the reliability somewhat. But don't forget, what we are talking of is the most reliable part of the computer system anyway. It's electronics. And in our judgment, and in the balance, we came down on the side of the use of printed circuitry, tried and tested modern electronics, not too far-fetched from the future.
Now, the biggest firm in the computer business is currently developing and selling hard a new computer language called, I believe, MPPL. You're not using it. Why?
you could ask this of many of that company's customers, because many of these have not yet decided to use it. Let me tell you the basic ICT policy in this field. It is to support international standards. And this is our avowed policy, and we are implementing this policy on the languages we are using on the 1900. Now, NPPL is so far from standardized that its name even has changed since it was first announced a few months ago. It used to be NPL, but perhaps that was too easy to pronounce. And we now have NPPL offered to that manufacturer's users, some of whom have decided to use it, some of whom have decided definitely not to use it. All I can say is we will watch the situation, and as soon as this looks like becoming or actually becomes an international standard, then ICT too will implement it.
To see where the 1900 was developed and where it's now being made, I drove north to the Stevenage factory to meet the Director of Production, Echo Organ.
That's certainly a pretty impressive machine. What is it? Well, this is ICT's new 1,350 line a minute printer. It prints at that rate and up to 160 print positions on each line. It's a vital constituent of our new 1900 series of computers. Now, to a layman, the laboratories and workshop here certainly seem pretty impressive. But can you really hope to match the achievements of much larger rivals in the field? Well, I suppose that judged by the standards of our biggest competitors, it's not so big. But on the other hand, we've got 150,000 square feet of new laboratory space here. The population of the development laboratory is about just over 1,000 people. Now, what we have to do is to be very discreet in devoting this effort to a few projects and making them the best in the world. We can't cover the whole of the waterfront. We don't intend to. Those we do tackle are going to be the best. But what about people? In the end, it's your people who are either going to keep you out front or hold you back. Would you be bold enough to say that your people are cleverer than those of your rivals? Or have you some system which makes them more productive? I don't think that we're more clever than other people. Certainly the productivity of British engineers is high. It certainly is. And I think that we have demonstrated already that we're able to produce a product which is as advanced as anything in the world. What about a system? Do you operate a different system here from what they do in most design establishments? Well, we do have our, I think it is a unique system here, in that we have set about building a very solid bridge between the design people and the manufacturing people. What difference does this make? Where does this help you? Where do design teams usually go wrong? Because the designers and manufacturing people, in respect of an exotic product like ours, when something goes wrong, they blame each other. And so what we do is to eliminate this difficulty altogether. We don't allow engineers to make anything. All their models and prototypes are made by the production people. And then, of course, because the first model has been checked and tested and it has been made by the production people, then when it goes into production, then there's a very good chance that the mass production is going to work as well as the early model. And furthermore, we don't allow the designers to mark their own homework. We take the early prototypes away from the designers, give it to an independent quality control organization, which reports direct to me, and they vet it. And similarly, when manufacturing start to produce, they're not allowed to mark their own homework, because this same quality control organization checks the output. It checks every machine for performance and reliability. You certainly seem to have achieved results with the 1900. I understand that orders for that machine are such that you've got to produce 5 a week throughout the next production year. How are you going to do it? Well, you've heard of the standard interface. Yes. This was developed here at Stevenage. Now, this enables units to be tested individually instead of being built together as a monolithic computer. And therefore, we can disperse our production of these units. We can spread it all over the country if necessary and ship direct to a customer's office from the production area concerned, so that the units never see each other and become a computer until they appear in the customer's office, and therefore we are saved the time and the labor of doing complete systems testing. This will enable us to greatly increase our output. Now, suppose the success was such that you had to, say, multiply your production by 10 times over the next 2 years. Could you do it? Of course we could, because it's merely a question of planning ahead. and putting in the plant that's necessary. Most of the production load for us lies in the electromechanical field. We merely have to buy more machines, more machine tools, numerically controlled, computer controlled, which will enable us to turn out more of a reliable and consistent product.
Finally, high above the Thames, in his office at headquarters, I spoke to Basil De Ferranti, Managing Director of ICT.
You may have produced a good machine, but this is a world of giants. What gives you confidence that you can survive, that you won't be outproduced and outsold all along the line?
Well, the first important thing to remember is how very rapidly this whole business is expanding as a result of the technological innovation represented in the computer and the advances in electronics. We are now able to replace nearly all forms of mental effort with a computing facility of one kind or another. This gives us the whole market of mental effort to go for, and this means that the rate of expansion will be such as is possible, physically possible, to get the machines in and doing all these things. It's an enormous and rapidly expanding business. This means that if we're aggressive, if we are determined to expand ourselves, we will have no trouble doing it. But of course, what we've got to realize is that we are a giant ourselves as well. We're a small giant, and that's probably the best thing to be in this business, because if you're small, that means one can respond that much more quickly to the continuously changing circumstances of our market than can the people who are lumbered with a far larger organization. Time and time again, Davids have beaten Goliaths, and this is just what we're doing.
Aren't your customers bound to think that experience goes hand in hand with size?
Ah, but experience we have as well. We go back to the very earliest days of data processing in the last century, and indeed we were in this country, indeed in the world, the first people to produce a commercially available computer. Let me just go back to what I was saying before as well. We may be smaller, although we're big enough, but smallness has very real advantages in this world, where, as I say, it's developing rapidly, and one's ability to respond to a change quickly and effectively and competently is more important than sheer size.
But staying out in front in the computer business means staying out in front in research and development, and you can only spend a fraction of your big competitors in this field.
Well, this is quite a misconception, if I might say so. In fact, the first thing that one's got to appreciate is that this business isn't just one business, it's several businesses. One must decide, first of all, exactly which of those several businesses one is in. We are in the systems business, from the smallest computers to the biggest computers. That's to say, we're in the business of buying particular sorts of components and devices, putting them together in a system, adding value to it in the shape of the software which goes with it, and then selling it to our customers. That's the first business that we're in. Secondly, we're in the processor business, producing a complete range of processors. Thirdly, we're in the card reading and output business, producing card readers and card punches. Thirdly, we're in the paper tape business, producing punch paper tape equipment and punch paper tape reading equipment.
Now this seems still a pretty broad field to me. How does it compare with your competitors?
Well, many of our competitors are in very much wider fields, which involves them spending a lot of research and development money on many other products. We are able to buy these particular products in for our range of machines. For instance, we buy in a lot of core store equipment, we buy in a lot of magnetic tape units. But by concentrating on the businesses where one is determined to make a success, one can get the best from one's R&D pound.
You say research tends to be more expensive in the States. Do you pay your people enough to prevent them drifting over there?
Yes, the cost of living here is different, and the attractions of living in England are a very rare thing. We have lost extremely few people in the United States, and indeed we find that we're meeting with some success in a recruiting campaign in the United States for people to come over here.
Now, so far you've managed without any government support at all, either moral or financial. Now you've got both. What difference is it going to make?
Oh, a great difference. It makes the whole difference between lack of purpose and purpose. We now feel that there is a national purpose to succeed in the computer business, and this means that all our suppliers, all the government establishments, all the universities feel that we are people who are worth going along with, and they come to us for advice on how they should handle their own research programs, and this gives us enormous benefits in the way of a spin-off from the very considerable technological programs that are going on throughout Britain today.
Now, to make a significant bite into the computer market in particular, this firm has got to grow. How big do you see yourselves being in, say, 5 years from now?
Well, over the last 10 years, we've grown by a factor of approximately 3. We anticipate that over the next 10 years, with this continuous expansion, not only in the business, but in the new ways of exploiting the computer, we'll grow between 3 and 4 times. That is to say, in 5 years' time, we'll be approximately twice the size that we are now.
That then is the machine, and those are the men who have enabled Britain to take this massive stride into the forefront of the computer industry.